Okay, this is a continuation of two other videos, so you might want to backtrack a few videos, and you want to look for the Markov chain. Yeah, the last two videos before this one. Okay, so this is the Markov Higgs signal, B quark, 5 axial forces, supersymmetric diffusion, and we're still talking about the Higgs boson, and this is my research on it. So here's the graph showing what we were looking at in the last video. So my thoughts are continued from our previous two segments. Look at the 0.6 and the 0.4 on the Markov chain diagram. That's these two here. Maybe the 6.04 means 106 and 104. The 7, TEV FLDT. Refer back to the Atlas preliminary data 2011 mentioned before in the previous video. I'll go back to it just to show it to you what I'm talking about. This data here we're looking at, okay? That's the actual signal. And we'll go here. Okay, so I googled, did some googling, got some PDF files here from issfinal.gov from Marchov, 1996. It says collisions at a center of mass energy of 1.8 TeV in the central unit of pseudo-rapid 7 rotations unsmearing of the inclusive jet cross-section. Higgs boson, HO and H plus minus, searches for, it's pdg.lbl.gov, June 2012. Mass limits for neutral Higgs boson and supersymmetric models. I don't know what that is, some sort of equation there. Okay, collisions and stuff, that's on the Google link there. Search for neutral supersymmetric Higgs boson and PP collisions. www.library.desy.de. PDF file. We report results of searches for neutral supersymmetric Higgs bosons and up to 2.7 FB. TAN meaning B. Higgs production in association with the B quark. So my thoughts, looking for neutral supersymmetric Higgs boson up to 2.7 FB, B meaning Higgs production with the B quark. So we'll look at that. Higgs boson. The easiest way to produce a Higgs particle is if the two gluons combine to form a loop of virtual quarks, since the coupling of the particles to the Higgs boson is. Again, that's a Google link. We're back to the graph again. So the formula based on the data that we've looked at so far is the Higgs particle plus two gluons plus combine, plus form, plus loop. See the loop in that diagram? Plus virtual quarks. There's the loops. Now look at your loops. E and A stand for, I didn't know what they meant. So E stands for electron in the standard model. A is the Y photon according to the pattern in the standard model, zigzags diagonally on the chart. So I'm looking at the chart here to figure out what's what. Okay. August 20th, 2012. My thoughts. Formula idea based on pattern of cells in your data. 5 forces. So what I'm going to do is show you what I think the next 5 Higgs boson particles are that are missing from your graph here. I'm not sure where they go. If they go under here, there'd be 1, 2, 3, and then the Higgs boson is supposed to go over here. And then the 5th one would probably go underneath the Higgs boson. That's just a guess, okay? I have no idea if I'm doing this right. So here's my formula idea based on pattern of cells in your data. 5 forces from the standard model. We have A equals Y photon, which is force 1. We have B as the bottom, C is the charm, D is down, E is electron, F is VU, mu on the neutrino, force 2. G is the theta, force 3, and HW boson is force 4. Force 5 is the axial force, and this is from Barry's research. See the previous segments. His name is Barry, and he's been doing research on the axial force. If you Google Barry axial force, it'll bring it up. So the new formula equation for missing standard model bosons is 1 is the Y photon plus 2, the VU muon neutrino plus 3 theta plus 4. W boson plus 5 axial force, Barry's equations, plus mass plus the boson equals Higgs particles plus complete standard model equals dark matter. So when I Google physical diffusion processes, and up comes this graph from CMS preliminary. says observed CSL limit, observed Bayesian limit, meeting expected CLS limit, ±1, ±2. And there's the graph with the different lines that match up with this. And this is DOHYY. Then this is MHGVC2. So CMS, YY Higgs decay into 2 photons, boson CERN Tevatron, LHC data. CLS limit is 7 TeV, wild data, new formulas add to CERN data, the idea girl says YouTube. So you want to take a look at the wild data that have the word CERN in them and 7 TeV. So we're going to be doing a cross-reference with that in the future. There's the diffusion center, Google physical diffusion processes, and this diagram comes up with some data. So this is an excess carrier density under non-equilibrium. Position, and carrier density CM3. General rate is that. It's on a nanohub.org. Quotes from Wiki. The above palette shows change in excess carriers being generated, green electrons and purple holes. With increasing light intensity, generation rate CM3 at the center of an intrinsic semiconductor bar. Electrons have a higher diffusion constant than holes, leading to fewer excess electrons at the center as compared to holes. Okay. My thoughts continued. Holes in Higgs boson, quark, gluon, plasma. That's the keywords that come out from that. These thoughts are going to continue in the next segment or the next video. Thank you for watching.